This is exercise number 6, and it tends to give people some problems, so let's go through it. In this problem, tides are created by the gravitational attraction of the sun and the moon on the earth. They want to know the net pulling force on the earth during a new moon, a full moon, and the first quarter moon. Then they give you a lot of different items for that. You'll notice that when you have a new moon, the moon is closer to the sun. That means that both the sun and the moon are actually pulling on the earth in this direction. When you have a full moon, you'll notice that on this side you now have the moon, so it actually pulls in this direction on the earth and the water on the earth, and the sun pulls in this direction. And notice that the sun has a much greater pull than what the moon does in comparison. And then finally, you have what we call the first quarter. And in the first quarter, you'll see that the moon is pulling down and on the earth, if you look at it in this frame of reference, and the sun is pulling in this direction. So in order to find that overall pull, which would kind of be like this, we've got to use the Pythagorean theorem. And so we need to do some just preliminary items right before we begin. And the first thing we need to do is just find out what is the force of the sun on the earth. The force of the sun on the earth. So we know the force of the sun on the earth is going to be equal to big G times little m, which would be the mass of the earth, times big M, and we'll call that the mass of the sun. And we'll divide it by the distance between the two squared. So if I want the force of the sun, that'll be equal to 6.67 times 10 to the negative 11th. We need to multiply that times the mass of the earth, which was 5.98 times 10 to the 24th, and then times the mass of the sun, which is much bigger, 1.99 times 10 to the 30th kilograms. We'll divide that by the distance between the two squared, which is 1.5 times 10 to the 11th squared. And when you get done, you'll end up with a force between the sun and the earth. So we'll put Fs of 3.53 times 10 to the 22nd newtons. On the other hand, we need to look at the force of the moon. So the force of the moon, we'll use the same equation, G times mass of the moon times mass of the earth, and we will divide all that by the distance between the two squared. So the force of the moon will be similar, 6.67 times 10 to the negative 11th. Multiply that times the mass of the moon, which is 7.35 times 10 to the 22nd, times the mass of the earth, and the mass of the earth is 5.98 times 10 to the 24th. Divide that by the distance between the two, which is 3.84 times 10 to the 8th meters, and we need to square that. When we're done, we find out that the force on the moon is about 1.99 times 10 to the 20th newtons. So the force of the moon pulling on the earth is significantly smaller than that of the force of the sun, but not by a whole bunch. You'll notice it's by an order of about 10 to the second. And it's because even though the sun's really massive, it's very far away, and even though the moon is not very massive, it is very close, relatively speaking. Now that we have those two values, let's figure out the force for each one of the values. We know that for a new moon, because they're both on the same side, all we have to do is add the two forces. So the force, the overall force, should be equal to the force of the sun plus the force of the moon. So that would be 3.53 times 10 to the 22nd newtons plus 1.99 times 10 to the 20th newtons. And when you add those two together, you get 3.55 times 10 to the 22nd newtons. So there's not a lot of difference there between this number and your final number, other than you'll notice we added about 2 times 10 to the 20th, which is that addition right here, so from here to here. If you do it in your calculator, it'll work out on each way every single time. The full moon, you'll notice that it is on the total opposite side of the earth. So because it's pulling in one direction and the sun is pulling in the other direction, we need to subtract the two numbers. So this force will be equal to the force of the sun minus the force of the moon. The force of the sun, 3.53 times 10 to the 22nd newtons, minus the force of the moon, which is 1.99 times 10 to the 20th newtons. And when you solve for that, you should end up with 3.51 times 10 to the 22nd newtons. So we see that there is a little bit of an effect on the Earth. This is why you get some of the tides that you do. In the first quarter, we remember that we have something pulling down this way, which would be the moon. So the moon's pulling down that way. We have the sun pulling the other way. So we need to find the other side of this triangle. That will actually be the same as the force that would be pulling in that direction. And so we want to know what is the last side of the triangle. This, remember, is the force of the sun. This is the force of the moon. And so the overall force will just be the Pythagorean theorem for that. So this is for the first quarter. And the overall force squared would be equal to the force of the sun squared plus the force of the moon squared. If we do the square root of that, we end up with, we need to do the force of the sun, which is 3.53 times 10 to the 22nd. Remember to square that number, plus the force of the moon, which is 1.99 times 10 to the 20th squared. And when you do your math, you should get 3.53 times 10 to the 22nd newtons. So there's not a huge difference there when it's in the first quarter. Just a difference when you have it as a new and when you have it as a full moon. And that's the end of that problem.